So rules of engagement, the more interaction with the audience, the better the talk will go. I think it's on. Yes. So please interrupt me. Not extremely violently, but so I enjoy interactions, as you will see. So if you have disagreements or whatever, I would be interested. So I'm talking something about the topic of multimodal AI in the future of universities. So this is a topic that would not have been possible without my very talented, biased as I am, students, who their names and pictures you see. But typically, this is a polite comment that, advisor, but I'm telling you, it would not have happened. You will see why. So, so that's part of a new research area for me. And also the mode is different. Typically, I write papers with 1 or 2 students, typically only with 1. But this is, as you will see, involves a variety of people. And this is research that I think requires. So that's the agenda today. So first, I will try to motivate what am I talking about and why. I'll talk about 2 applications. One is what I call holistic AI for medicine, short for HAIM. HAIM or Chaim is the Jewish word for life. And then an application of this in a real world setting in a hospital system that I work closely with at Hartford, Connecticut. Then a corresponding idea of holistic AI for hurricanes, holistic model. I use them in the same. So this is sort of, at least you get you a glimpse of the research aspect of the talk. But what I also think is important is I think this type of work has, in my opinion, serious implications on how universities should be structured in the future. And I will also use the opportunity to say a few words about the future, the implications about the future of the field I'm coming from. I recognize the talk is more broadly than my field, but I would like to use the opportunity to tell you a bit about that, and then talk about the research and education agenda for the future. So let's talk about first motivation. Okay, so let's imagine our own experiences regarding the interactions with our own health, right? So let's see what is involved. Let's say I'm not feeling well. I go to see a doctor. And typically, doctors, especially if they are uncertain about what is going on, they will ask some scans potentially, an MRI and CT or X-rays. It's quite usual. They also use radiology reports. If they ask a scan, they will read the radiology report, not only the scan. Typically, the physicians will read the report because they are not so much experts in reading scans. They also, in a hospital, the doctors would read other doctors' notes and nurses' notes. That's quite typical. So language. Of course, they utilize lab results, electronic records, and so forth. And often this in time series. You might actually use data today from the day before and so forth. You have a time aspect to it, and not very commonly, but increasingly genomic information. And this is just a small collection of the data. And in fact, human doctors are trained to do that, right? So it's a natural question. So this is, the corresponding terminology in scientific matters. Scans, that's really computer vision, language, tabular data, and so forth. So given that humans do use this, why not machines, right? Agriculture. Well, I selected the example. The A on Texas A&M, I think it's agriculture, so I think it's an appropriate place to. Although in the end of the talk, I have a little puzzle for you. I would like you to, after you see the talk, please tell me what A&M would have to mean, right? That's a challenge for the audience. We have prizes. So agriculture, let's think what is available. You have images. So I don't talk about that, but I'm involved in application agriculture in Africa, actually, in which we have pictures, satellite information about the entire country. In fact, in Ivory Coast, where we have data, cocoa is the biggest. We have for every parcel in the land from Google Earth, we have images. We also have meteorological data, temperature, rain, pressure. You also have Earth-related data, ground, what is the ground fertility, what are the crops, and also we know yield data. After surveys, we ask the farmers what. So this is an example. You might not have a lot of language, but the rest you might have. But even if language sometimes might be relevant, because language has relevant information about, in articles, let's say Wikipedia, about a particular geography, although we don't use it in this case. So similar question, can machines use multimodal data to make better decisions on what crops, at what time, with what fertilizers and antibiotics? Climate change. Well, where, at least in this area, not too long ago, Houston has been inundated with floods. So how do you predict the direction and magnitude of hurricanes, which is unfortunately very much so in our future, increasingly so, at least this is what recent evidence suggests. Historically, if you look at what the nation and the world is using to predict, let's say Hurricane Katrina, if you remember, is partial differential models that have been developed in the last 100 years using essentially Navier-Stokes equations. So that's the PDE models that have been utilized, and there's the European model and the American model, and often they disagree actually. But if you think closely, what data do you have available? We have images, because we have historical images from hurricanes. They are these aeroplanes that go around and have information. You have physical data, temperature, rain, pressure. You also have language. You have global warming articles, books, and so forth. And based on this data, why not use this data potentially with the PDEs? I'm not saying we forget the past, but I will say, why not we use multimodal data? Multimodal means multiple types of data, structured and unstructured, in order to predict the magnitude and direction of hurricanes. So hopefully I use some examples. There are many others. But in addition, I would like to motivate what I call a human-centric analogy. Let's think about how we behave, right? So we have 5 basic human senses. We have, as a way of interacting and understanding the world, we have touch, sight, hearing, smell, and taste. COVID compromised some of them. But there might be others. I'm not saying that's the only one, because there's some debate about other senses, but everybody agrees that these are the case. So definitely multimodality is a fundamental characteristic of human life. So it's not like I'm thinking of something completely ridiculous. So we utilize to understand the world. So why not machines doing that? So that's the motivation. So the motivation, therefore, at least in 2 areas that I have some experience, is to give you some examples of what can you do with this perspective. Okay, and I would like to preface it that I have been, fair to say, a skeptic of deep learning. My friends suspect, they were very surprised that there's a seat over there, sir. So, they find it unusual to do it. But something I believe strongly in life, that people should adapt. With more data, more information, we adapt our views. This is part of my adaptation. And not that I think all my concerns are gone. I told you about that. But it's very hard to ignore the success of this field. So what I'm going to talk about today, about the holistic artificial intelligence for medicine, this is a paper that just appeared in Nature Digital Medicine together with my group. And as you will see, all of these, or some of them have graduated, but almost all of them are doctoral students in my environment. So, what is the vision of the vision of this research? I would like to remind you the story of IBM Watson. It's a little bit problematic at the moment, but when it appeared, it was one of the most exciting things I've heard. So just to remind you. So IBM Watson developed. Do people watch Jeopardy at all? Nobody watches? Okay, a little bit. I watch sometimes, but I'm very embarrassed. I understand maybe 5% of the questions maximum. When I answer a question, maybe I feel, but I enjoy it. It's also at the right time where I'm trying to relax. So what did IBM? IBM developed an algorithm based on natural language processing primarily to try to answer questions, and it beat the best human players. When I saw it, I thought something is changing. I have not worked in this area at all. I mean, so unfortunately, then IBM tried to change medicine. You know, we created algorithms for predicting, have prescribing in the context of healthcare. And I have to admit, it has been a significant failure. It has not. In fact, I have a close friend who is a doctor at MD Anderson in Texas, who actually adopted, not himself, the hospital, $65 paid. And it was an unmitigated failure, I would say. But it doesn't mean the idea was wrong, right? It is just this particular implementation. So is it possible to get... So the question is the same. Can we use holistic perspective of AI to make predictions and prescriptions in medicine? So the key question is the following. We have data that have different modalities. For example, in machine learning, people are used to utilize tabular data, right? Separately from that, the computer vision are used to using typically what's called CNNs, neural networks of some kind for vision. Similarly, different kinds of neural networks for language. So what we developed is a unified way to make, just to give you a little bit of example. My hope is, and the level of the talk is such that I was told that this is a broad audience. So this is not that there is a gigantic amount of mathematics, but it's low on the mathematics, right? So, so I would like to give you a glimpse of that. And if you are more interested, please take a look at the paper. So that's an example of a structured electronic health records in which you see the time. This is from a real, a real experiment, a real example. You have the various values and so forth. Right? So that's tabular data. We also have, out of this data, we also have time series. Let's take, for instance, this is, let's say, blood pressure over time, right? So we have developed methods that extract signals from that. For example, here's a signal. What is the maximum? What is the minimum? The various number of peaks, a lot of information. So we have an automated way, this is not particularly difficult, to extract relevant information from a time series. Of course, potentially with loss of signal, but we had 700, 800 factors from that perspective. Then we have a way of extracting. So the other part is unstructured. So far I have about structured data, but we also have unstructured text. So this is an area that has witnessed in the last year and a half an enormous, in my opinion, improvement on its ability to process. Not too long ago, this was not used in this work. I have played, I'm not an expert, but I have played with OpenAI's new software, ChatGPT, I think it's called. I don't know if you tried it, but in my opinion, scientific developments go and at some point accelerate. I think this is in the acceleration point. If you have not experimented, I think it's a good. I'm not saying it's perfect. I'm not suggesting that, but I think it's a significant improvement. So there are these large language models. One of these models is clinical BERT. BERT is not the 4 digits of my last name. I did not name it. Called BERT. People think I'm immodest, and so. But these are large language models. So this is a little example in which you have events like, so for example, this troponin 0.13 measurements, and the warning is outside normal. This is language, right? So clinical BERT is trained on WebMD, on gigantic databases, in this case, on medical information. You can, of course, in other areas, you train it on different information. So, so therefore, out of this effort for clinical BERT, you train and you get in the end a feature extraction setting. This is a neural network. Most of the biggest developments called the neural networks are called transformers, right? So these are very new data structures and systems for which I'm not working. I'm just a user. The output of this is a 768 vector of numbers that, if you ask me what they mean, God knows, I do not know what they mean, although this is one of the disadvantages of loss of interpretability. So everybody will understand what a troponin method and this method outside normal, but the output of this is numbers, okay? That's already a disadvantage, but let's play along. We shall see we have some benefits from this story. EKGs is another. In this case, we use EKGs, not the actual EKGs, but the report that comes with EKGs as language. Similar, in this case, we use not clinical BERT, but another related open language model. We can select whatever we want, which is BioBERT. So in a sense, what are we using? We are using somewhat, not only the software that supports, but also totality of human knowledge. WebMD has gigantic number of papers on information. So we are basically utilizing, in addition to the data, we are also utilizing, if you think about what these language models include, they include knowledge, correlations, and so forth, of what the human investigations has found over multiple decades. Right? And we try to exploit that. Images. On images, again, we have, for example, in the application, we had X-rays. We pass it through a CNN, and we outline here again a vector of characteristics. What neural networks? The property neural network we use is its ability to do nonlinear feature extraction, which I believe this is a strong characteristic of neural networks. The price to pay on that is that we have lost interpretability, okay? But we have gained in representation. So what do we have now? The effort was made out of all the signals to transform into numerical values, right? So what we have, therefore, we have images, we have an embedding. This is a vector of numbers just before they make a prediction. So, for example, say you want to find mortality from of a patient that has an X-ray, you train it, but you don't care about the prediction. You only care about the signal that it collected just before. So you collect this signal. These are these things, this embedding. You do it with about chart events, lab notes, and other embedding. Then time series and so forth. Whatever data you have, you create with the appropriate architectures using transformers, using CNNs, using just the raw data. We utilize embeddings, okay? And then once we have that, then we train a regular machine learning to we train. Let's say our target is the person going to leave the hospital or not? With all this data, we now train it. Yes.
So the loss functions of all of these are the same, like
the loss function. It's a summarization in a way. In trying to predict what we want is what the signal that the corresponding methodology found relevant. And in this particular case, if it's a classification problem, it's misclassification. If it's a regression task, it's some loss quadratic and so forth. But not fancy. I mean, simple. I mean, things that you will do anyway. Okay. Any question? I mean, it's not rocket science what I'm saying, but so putting this together in an additive way. So let me tell you now where we applied it. So there's a very famous in healthcare. I don't know if anybody works in healthcare here. So you would agree with me, I hope, that to get data from that fulfills the HIPAA rules, the privacy rules task, it takes a long time and sometimes never to get this data. But there is a famous data set, the so-called MIMIC data set. This is data that is in a Boston institution, the Beth Israel Hospital, but is actually public. It's semi-public. You need to have a little bit of pushing the envelope a little bit. You have able to get a public data set. But we have a multimodal public data set, a rarity in publicly healthcare. And the reason is because, the nodes, for example, might have personalized information. It might say Dr. Bertsimas, who is a professor at MIT, and his wife, blah, blah, blah. You have to, but it has already been done for us. So we have data on the mimic, that has all of the above. It has electrocardiograms, it has X-rays, it has, of course, electronic medical records, it has demographics, and so forth. It's a truly multimodal data set available. And it's about 34,000 records. These are patients of the emergency ICU rooms, Beth Israel, as I mentioned, and the data have the following modalities. Okay. And what are the targets? The targets we utilized is a lot. We utilized mortality prediction, predict if the patient is deceased or sent to hospice or alive when we have historical data, then we can say, did the patient survive or not survive, right? Mortality. Diagnosis, we have selected, because everything is, on X-rays, it has to be related heart disease or lung failures and so forth. So the types of questions to predict if the patient has a certain disease is based on appropriate. I mean, you don't have lung, and then you ask if a person has a foot. It's appropriate for the question. And then length of stay, to try to predict if the patient exits the hospital in 48 hours. So the reason we selected this, because they combine, this is an academic study, yet. Later on, I'll tell you about the real study in a real world environment, in which we try to see which of these characteristics could be, because it might be that in some cases are a complete failure. I mean, it's not a priori clear that this idea is useful. So here's the first surprising result. When I saw this result, I actually questioned my students, something I don't obviously do very often. So what have we been teaching our students? Me too, I mean, you, all, myself. We have, let's say, data. Let's say data, tabular data. Tabular data involve, let's say, blood pressure. We know the label of its column. But what do we do in machine learning? We forget the label. We just use it as data, and we try to predict 1 or 0 if it's a classification problem. But we lose the content. Am I wrong? Somebody here has done classifications, Am I correct, sir? You seem to be nodding.
You're right.
We are forgetting context, right? So if we have two identical data, but they mean different things, they will give the same results as a conclusion. So we did the following somewhat crazy experiment. We take, instead of saying 16.2, 162, this is supposed to be blood pressure, we say the blood pressure of Mr. X is 162. The systolic pressure is 162. So we basically input the data, not as numbers, as language, right? And then we give this information. We run a classical machine learning model, and then we run a language model. This is not yet multimodal, just to illustrate that that is, in my opinion, I couldn't believe it. The results are that if you use tabular plus the text, in other words, you use the numbers, but you also use the blood pressure you get predictions for various characteristics, improvement, from 1% to 10%. So, moral of the story, if you remember one thing, please remember this, that thinking about differently. So where is the benefit coming from? Any ideas? What's that? Context. But in addition, you use clinical BERT. You use the huge knowledge. So you use your local data, but in addition, you use the human knowledge that humanity has generated, which in machine learning we tend to forget. We tend to forget. So this, after the fact, after some reflection, you say, of course, but it took me 2 months to be convinced that this is correct. So
you only enter the text data, but you didn't really give them the knowledge, right?
No, but I'm using clinical BERT. Clinical BERT has been trained on all the Wikipedia, all MD and so forth. It knows that blood pressure of 162 combined with diabetes of this has this level of danger. And not only in the data that you have, what you have is 34,000 records. You have hundreds of millions of records that the humanity has utilized, directly or indirectly. So in other words,
That's the part they acquire the knowledge.
this is what clinical, these large language models utilize. Why is it that chat, it's the same story. Why is it that chat GPT does amazing things? It's because it utilizes, it is being trained on a lot of stuff and with increasingly more and more complex structures. But this is my current understanding. I might be incorrect, but my current understanding is that we utilize totality of knowledge. In other words, when we write a paper, let's say our process of writing a paper, hopefully it improves on the previous. Implicitly, this is, we basically utilizes everything has been discovered in the past. I don't understand fully the way we, something more research is needed, but that's my intuition of why it improves. I find this, I hope you agree with me, I find it unusual that.
Why do you initially wouldn't believe it? It's a genuine improvement. What surprised you?
What surprised me?
Yeah.
What we have been doing the last 20 years, what I, not you, I have been doing. I was forgetting. I wrote a book on the damn thing. I wrote a book on machine learning that completely ignored. I mean, I have good company on that, but completely ignored that. And I have a high degree of belief that it's not that it was what we were doing was nonsense, but by forgetting context. Of course, 10 years ago, these things were not available. Now they are, and increasingly more so. I believe it definitely goes against the tide I was going. Maybe, more perceptive people could, but I was surprised, honestly. I did not expect this. I suggested to my students outside chance, and it was correct. So something to remember. I hope you would remember this. It's somewhat, it relates to my key story, but this is also an interesting result on its own. And here's the Haim business. You forget the exact results, but here's something that I find it. This is not something I have been in this area of healthcare, that's sort of a significant portion of my work. I care about the method, but most important, I care about the answers. And what has happened is that mortality, you predict 11 to 33% improvement. That's a big improvement in machine learning methods. Disease classification, 6 to 22%. Length of stay, 8 to 20%. And this is, the improvement is over tabular data. Forgetting this is what I was doing before. In other words, if you want to predict predictions, you use tabular data. You forget that you didn't have the other data. This is what you improve. I mean, for those of you who work in this area, this type of predictions are not, it's like if I was doing 1% prediction, it might be a fluke. But these are a significant collection. There are target here, one target here, 12 here, 14 targets. In all of them was something positive. So my conclusion from this exercise is that there's something to be said about multimodal analysis. And if you look at, this is harder to see with the colors, but overall, we did for all these targets, if you observe, as you add more and more, there was, concave improvement. It doesn't snow, but the colors suggest that if you add more and more modes, you have increasingly improved performance, and after a while, you don't improve. Not in every case, but generally speaking, the more modes, they capture different things. I mean, this is not by itself surprising, because if you look at human doctors, when they make decisions, let's say they need to decide whether a person have to go to surgery or not, they try to utilize lab data, computer vision data, they consult reports and so forth. So it's not too surprising. So what I would like now to say, any questions on this? This is sort of my first message.
Is that possible? How many different sources of data, they kind of generate a conflict, and then eventually the machine get confused, just like sometimes.
Of course, it happened. On the other hand, over all 14 factors, and since then we've done many others, it doesn't get confused. In other words, it is, you know,
You need enough data.
we need enough data. We had 34,000, like a tiny little. No, I'm not suggesting that you have 10 records and you try to apply this. Of course, these are data hungry methods. These are not, you know, these are incredible. The biggest impediment is the HIPAA requirements that prevent sharing. You know, I have been I have been in this business for healthcare for 15 years. I now have the relations. They trust me to give me the data. But my goodness, for the first 5-7 years, it was, you know, hitting walls. And it's only because I have some experience in relations that, yes, sir.
Language to determine additional factors which you could then reuse.
Yes, active research. This is an area that, as I mentioned, it's now that it's exponentiating. We are trying to understand. We have some partial results and so forth. We try to look at code you cannot. But we do experiments where we change the inputs to understand if there's what type of specialization there exists. So some of these models have parameters, hundreds of them. The complexity is beyond the human ability, at least this human's ability. But it's an area of very active research, not only by us, by others. Yes, sir.
The assumptions we are making in taking these inferences.
Assumptions I'm making. I don't use many assumptions. I don't state mathematical theorems. I use data and I make predictions, but I test out of sample.
But then
I think I see where you are going. My view is that this needs to be retrained. And in fact, we retrain them every 6 months. I mean, this was an academic study, but in what I'm about to tell you was a real study. We retrain every 6 months. For example, if we had a model in 2019, no COVID, with COVID, distribution will find completely different. We have to retrain and adjust. So the idea is not a static story. It's multi-model, but constantly adapting. Humans do that too. I mean, at least smarter humans. Because, yes.
Yeah, so regarding the
Clinical birth.
so the output is
A 978 vector.
768.
Yeah, 768. Yeah.
Can you just comment on that? Is it user specified?
No, it's fixed.
But won't you think if you increase the number?
You can't. The smaller you can. That's the biggest it goes.
But you would suspect that the more data you add, you would need larger vectors in order to capture that.
There's no ability on that.
There's no ability.
At least there might be internally, but the ones I'm a user, I'm not a developer. So that's what we have.
But wouldn't that be a limit by?
Could be. But you are already thinking improvements, my friend. I'm thinking, what's the phenomenon? A step at a time. Yes.
Previously, you think like treating images independently.
Independently, yes. Yes. We don't cross train. Only the very end. In other words, the logic of the method. I'm not saying it's the best method. I'm just telling you a method that works is that you train independently and only in the very last step you combine. In other words, you take a sufficient, what we think is sufficient, or maybe not sufficient, but nearly sufficient statistic, and then we cross train. We don't cross train pairwise. Not at the moment. But there is more work to be done, my friends. Other questions? I opened the door. Yes.
So we think of the clinical bird as like a knowledge representation.
You can think of that. It's a way of representing the knowledge that allows additional data, private data, to improve things. I mean, to be honest, I don't know if it was designed like that. That's the way we use it. There was a question, sir? It's utilized in clinical birds. Not every single textbook, but manual, for example, which manual in medicine is included. Okay. All right. At least you have, I managed to cover the paper. Now I will tell you something that is, in my opinion, more important than the paper. So in my book, of course, talking to an academic audience, of course, we should write papers, and especially for the young people to get credit and appropriate. So, but in the end of the day, in my view, leaves the test of time if it's actually being used in the real world. And this is the purpose of this, is to actually be used. So this is I have a long relation with Hartford Hospital System. This is about the largest hospital system in Connecticut. It has 7 hospitals, roughly 2,500 beds. It has an operating revenue about $5 billion. It's not, as most hospitals, is non for profit. It's a large hospital system, very representative of the US network. It's not like Mass General, which is a very research-oriented hospital. It has some research, but that's not the major purpose. It treats people. And we have working very close. I have been working for the last decade with them. That's actually relevant, believe it or not. It's perhaps more relevant than the mathematics, than the approach. So these are the hospitals. And what we would like to do, we have created a software that is currently in use daily, not in use experimentally. On a daily basis, people use that. And in particular, we focus on these decisions. So for every patient in the hospital, we have knowledge, all relevant data. In this particular case, we don't use images because I have not yet overcome the HIPAA requirement, but I have data from everything else. So, and the types of things we try to predict is discharge, whether a patient in the next 24 hours or 40 hours will be discharged. So what's the probability of that? Where the person would go. Is he going to rehabilitation, to home, or to heavens? Therefore, mortality risk is relevant, ICU risk, and so forth. These are operating characteristics that are relevant for a hospital, right? It's not like little details. And just to demonstrate that this is real results for all hospitals. AUC is the area under the curve. It's a measure of accuracy for those of you who know. High is good, and the highest is 1. So for mortality across the board, these methods give you roughly 90%, 90, across the board. For destination, it's about 87 and so forth. They are not perfect, but they are very respectable, right? So that's on the AUC. This is sort of the academic perspective. But they don't care much about the academic perspective in the real world. They care about something far more mundane. So, and we also calibrated. Machine learning models have a typical weakness that they don't calibrate well. Namely, that what you predict in reality, they have to be 45 degrees, right? What you predict is roughly correct. That's actually reassuring. So I have done experiments where the accuracy out of sample is okay, but when you calibrate, it's not so okay. So something I would recommend for the young people in the audience, please calibrate, make sure that it calibrates, because often the damn thing doesn't do it as well. I mean, this was an experiment that we've done after we have actually started using it, because somebody asked me, to be honest. I didn't do it myself, willingly, in other words. And here's what they see. So this is an actual from the software. This is a particular day, particular patient. The colors, red means mortality either is high or going up. Green means the person is ready to go. Yellow is not yet ready, but it's getting ready. So red means be careful. Green means is ready to go. Yellow means getting ready to go. And in addition, you see these arrows, whether it's going up or down. And in addition to that, you also you can click on a number and you can see some attribution. This is what's called a subplot. Subplot is a method, for those of you who know, who basically attribute why the answer is what it's a limited level of interpretability after the fact, right? So I'm not saying that our method is particularly interpretable, but it's not zero interpretable, right? So, and what we have found, first of all, comparison with humans. So because the doctors, for many of these things, make their own predictions. When these are expert people, we entrust our lives to them. So when somebody comes, they actually say what the prediction is, and then they modify this prediction. And based on this prediction, they make decisions about who to prioritize, that the person exits and so forth. And we have found that across the board, we have, like the AUC of the doctors and us is additive 20.20. In other words, we are 0.85, they are 0.65. Machines, in other words, are hands down better. On that, we have high confidence on this result because we tried it multiple times. Admittedly, we are not playing against Usain Bolt, right? The top athletes on the world, with doctors that have no particular expertise in prediction. But that when we know it beats humans in what they're supposed to do, that's actually positive already. So, so the methods we have found is that they are stronger in prediction. Of course, this on its own is not so fantastic. We have done an experiment. That's why this was a period where this was slightly post-COVID. We're not post-COVID really, but somewhat post-COVID. We've done a ABT test. In some units, we applied our method. In some units, we did not. And what we have found is that for all units that did not use, the length of stay increased 7%. Am I doing something wrong? Yeah. In the units that we applied, we decreased 4%. So there is an incremental 11% improvement. Now, you might say, what's the big deal of that? Well, just to give you back, this is length of stay only. So length of stay, average the various, a person in the Hartford hospital system, which is a typical US hospital, the cost, the cost for a person is about $10,000 a day. We decreased about 10%, which is roughly half a day. It's about $5,000 per day for days. So if you do across the system, it saves the hospital $70 million. I mean, admittedly, not one hospital, the entire system, 2,500 beds. So you might say, what's a big deal? It is a big deal because these hospitals most of the hospitals are on the red. Most of them are. Some of them, as this hospital was near zero. So 70 million, if it's realized, will allow the hospital to do expansions, to hire more doctors, to provide. It's not like it's a profit center that people put in the pockets. Maybe they give more bonuses to some doctors, but I think it's a significant finding in my view. And based on these things, the people have used just to demonstrate that I'm not completely, in the sky. I'm somewhat on the sky, but at least I have a parachute. We have one example. What we've done added something positive to the environment. Of course, the applications of HIME are significantly many. For example, currently, this is current work we use for detecting domestic abuse at the Brigham and Women's Hospital. And as you know, if somebody has, let's say, unfortunately, they are typically women, when they come to the hospital, they don't exactly are forthcoming that they are being abused at home. So, but we have images, we know their injuries. We also know radiology reports, information about their histories and so forth. So my colleagues at the Brigham, particularly, there is a lady who I have a lot of respect, who is the head of the radiology department at the Brigham, have classified 4,000 cases. So what we would like to do, we would like to develop a method that just on the data can detect abuse or not, and then alert the corresponding players who is, if the person is abused or not. Human trafficking, similar. Red cap events. Red cap events means if somebody is about to have a potentially life-threatening event in the next 5 minutes, if you detect it early and send the red cap teams, you can save a life. Because most people die because there's by half a minute or so. I mean, not in cases, but often. So if you are able to utilize all this data and predict something happens. I could go on, but what I'm going to say is that the application of multimodal data in medicine is, in my opinion, endless. That is, this is just one of the reasons I engage quite a few of my students is because this cannot be done on an individual basis. The code, by the way, the code is public domain. So again, I'm not claiming that the code is the best in the world, but this is something that other people can use to do it in their own for their own data. I do believe this is a direction that I believe will happen regardless of us. So, us meaning my group. So that's the second part of the talk. Questions? It was an application. Yes, sir.
What is the implementation cost of this software in the clinical?
The implementation cost. So I do not know it because I did not pay that cost. What I know is this: for this to be implemented, it takes 2 weekly calls for myself and members of the group, because it's not so much, of course, having spent 10 years, they trust me that I won't do garbage to them. I care about the people, they know that. But I have to convince humans who have no knowledge on this. The calls now, because all 7 hospitals use it, involve maybe 20 people, 20, 30 people. And it's reinforcement between. So these 30 people for an hour every week, you can count. They are not paid little. So, but I don't know the cost. But the most important thing is that the hospital has made a decision that this is important to do. So it costs money, but I don't know how much it costs.
It's all on their side.
Yeah, I mean, it costs to develop the software. There were 10 graduate students over 3 years, sizable amounts of money. But but we open it up. This is not something I would like other people to experiment and also improve. Whether this is the best idea, I'm not so certain, because this is the other thing I'm thinking is that I have utilized 2 methods personally. I often start a company. Not necessarily to make more money, I have enough. It's to make certain, because students come and go. What am I going to say? So I have engaged a company on my side to support the data. Students cannot do that, but the research is active. So we learn new things and so forth. My hope would be others would use it. I mean, I definitely believe, you can tell, multimodal analysis is here to stay. I mean, and then improve. For example, the gentleman told me that maybe you can cross. There are many ideas that you can use. We have something that works. We shall see how. I'm not claiming what IBM was saying. We are the best thing after Swiss bread. So we have a method. The method passed muster in this case, but there might be others that it doesn't. And in this case, it also passed muster, I have to admit. So the second application is hurricanes. Yeah, meteorology, on which I know. Healthcare, I can say, while I'm not an expert, I know something about. Meteorology, I have to admit, I knew before that very little. So I'm not an expert in meteorology, right? So together with 3 of my students, we addressed the following question: can we predict hurricanes from data, from multimodal data, not from PDEs and so forth? I remind you, from Hurricane Katrina, it's actually stuck in my mind. So one of the reasons of the failure in communication, but there's also a failure of the models. Model, which was New Orleans, said it will go this way, and the American model will go the other way. Both predicted that it will miss New Orleans. It didn't. So models, unfortunately, are faulty. All models are not useful. I'm not saying they are not useful, but in this particular case, they were not that useful. So I would not bother you, but we have historical data about 3,000 hurricanes. This publicly available data, NASA has this data. And in addition to that, there are satellite information. We know what is happening. We have what's called reanalysis maps. These are the maps of the hurricane at various levels. Fairly detailed data. Okay? To make the long story short, because it's a similar story, use similar architectures, we have found something that if you were to tell me up front, given our knowledge, I would be doubtful. But what we have found is that if you use small numbers are good here. This is the mean average error from data we have seen Eastern Pacific regions, and this is the North Atlantic region. So if you use deep learning alone, the error is 10.7 units. The most important, I want you to have a bit of a feeling. If you use deep learning and the multimodal, namely roughly the Haim framework, you get our best results. The best statistical models that utilize statistical models, not PDEs. These are the PDE models. The PDE models, in this particular case, are the best in class. In this case, they are not best in class. But it's fair to say that a professor and 3 graduate students that know some deep learning, using this totality of data, can find maybe not the best, but close to state-of-the-art models. That's not the most surprising part. The most surprising part is now. Namely, so we have something respectable, enough to be published in the top meteorological journal. What is particularly exciting is that if you combine this data, combine our results, and then averages with the dynamical model, the real model, you get 5 to 15% across the board in every experiment we have tried. So in other words, multimodal analysis, in this case, improves the current state of the art that took 100 years to do. I find this, very optimistic because we are no experts. I mean, we have little understanding. After 5 revisions, and I know a little bit more because they forced us to. But I think it's an interesting story and it says that the new era of AI can be usefully combined with the historical 100 years history of Navier-Stokes equations and numerical solutions and so forth. So I view it not so much we have provided a final theory and then we are done. It's to illustrate a direction that I think is promising. There are many other applications of these methods. Precise agriculture, I have been working on that. Wildfire management, monitor climate effects, weather prediction. It's pretty endless. And in recent years, I have been involved in applications that you would not think. Law, for example, we're currently involved in an application that, this is one of the largest insurance companies in the world that have roughly 5-10 million contracts a year. On the simplest contracts, just the language alone and some tabular data of the losses, you can actually review and do, I would say, at least equally well as a junior associate, not the most senior people in these contracts. I mean, my intuition is that combining, in this case, only 2 modes, language and tabular, could help. Human resources, drug development, digital humanities. I mean, I'm not an expert on this, but and only very recently, I have been primarily an observant as opposed to myself participating. But you can understand significant things about literature, and so forth. People are using it. I'm not certain how much you use multimodal, but language, and I think if you combine it with some information from different kinds of language, like papers and so forth. So I would say this is promising. I have a few minutes. Yeah. So what I would like now to talk to you about the last part of the talk. All is good and nice. Okay, here's a professor who tells you about his latest results and so forth. Most likely you will forget some of this. So when I ask the sixth speaker asks you what was memorable about Professor Bertsimas, you might not remember exactly what I talked about. I would not perhaps remember putting you on. So the question is, but all of us would like some comments on what the implications of these things are for our collective future and what perhaps we can modify thinking about it. So if you think about it, universities over centuries are organized hierarchically and vertically. Namely, you have the School of Engineering. We are here in the electrical engineering department, I think. I was visiting before the industrial engineering, system engineering. There was another department, something about I made a gentleman from that, and so forth. So I think this is how they are structured. In particular, MIT, my own institution, has been organized for almost 70 years vertically in 5 schools: schools of science, engineering, humanities, management, and architecture. Okay, very recently, a year and a half ago, we have a horizontal model called the Schwarzman College of Computing, it's called. But it has some elements of horizontal, meaning it doesn't have, it's not a school, but members of various departments of schools participate in that structure. So typically, each school has multiple departments. I'm telling you things that you know, but it's good to observe, right? ECS, electrical engineering, computer science. I don't. Maybe here we have it separately. EE is different than CS, mechanical engineering, and so forth. And I would say this reflects history and tradition, right? This is how we have been organized. We don't even question it. Right? Every day you have questioning the department structure. Is the right way of structuring the environment? So the question is this the right structure, or should we adapt? That's the question I'm asking. I'm not saying this is what a terrible mistake, and it has served humanity well. I mean, you know, we have a working environment for institutions. However, it is my belief that real world problems do not have labels. For example, global warming is not only a physics problem or an engineering problem or a mathematical problem. It's a problem that collectively needs to be addressed. Medicine is not a biology problem or a chemistry problem or a computer science problem. It's a problem. To be able to say what is the right intervention for these patients, it combines, in my opinion, should combine multiple things. So given the available data in electronic form, both structured and unstructured, at least it makes sense to me to utilize the available data for better decision making, particularly use a multimodal structure across the board. Across the board. So these are some reasonably safe predictions. Number one, in my view, you know, of course, predictions are cheap, but the only advantage is that I have the floor at the moment. So, so multimodal data, in my view, will increasingly be used across the board. It's already happening, but I think it will accelerate. Second, I also believe that multimodal machine learning, not necessarily what I say, the specific technologies, you know, the idea, will be the predominant methodology for predictions in all fields. And I also believe that universities of the future will be organized horizontally, not vertically. Why is that? If it is possible, let's take hurricane prediction, weather prediction. If it's possible, the students, admittedly very good, and a professor, you know, is dedicated, but God knows what he knows. He doesn't know that much in this field, can combine existing knowledge and new knowledge and can improve the state of the art. Clearly, there is something to be done where the AI analysis will be helpful. So it makes that we train students in the meteorology department, MIT has a Earth Monetary Sciences, it's called, to train them in this area. It doesn't take a genius on that. Or let's take healthcare. In healthcare, future medical doctors, the best, they know perhaps regression and perhaps logistic regression, full stop. They do not know, they are not trained in that. If you look at the training of medicine in the years past, it was roughly 100 years ago that Hopkins started educating physicians, and the model has not changed. You know, if you look at what they do, they are not knowledgeable. It's not the young medical students, very talented, good people. It's just that we don't train them appropriately, at least in my opinion. So I believe that classes in multimodal machine learning and also decision making, I use optimization as the language, but really I mean decision making, will be the core basis of many, maybe all fields, augmented by specialized topics, perhaps utilizing specific nodes. I'll tell you what I have in mind. That if you think at the moment, what is the core that everybody, at least at MIT, which is a technical institution, takes? Everybody has to take calculus, mechanics, electromagnetics. This is the core curriculum. today. I don't know what it is at how I would not be surprised. I mean, most people take calculus. And I'm not saying these are useless knowledge. I don't believe it. Of course they are useful, but I do believe we should train the entirety of the university in users, developing methods, in developing understanding and utilizing this type of methods that can be helpful for their education, which is atypical because now proposing that in the same room you have medical doctors, law students, engineers, physicists, mathematicians, and so forth. It has it at the level. If you teach extremely mathematical topics, I mean, nobody would follow. But you can talk about the essence of the topic only by emphasizing the application. You can have applications in medicine. I gave you two, and there are many others. I also believe that new fields will be emerging. So this is sort of the first step. The second step, of course, this is the basic knowledge, a horizontal basic knowledge. In its vertical, then you have to engage the faculty in its particular area that combine the old knowledge and the new knowledge. And on that, that's not a difficult task. That's not an easy task because you need to re-educate people that have they are not being educated in this field. So I'm proposing that this will take quite a bit of time. I'm not suggesting, especially on established universities, it will happen tomorrow. But if you prepare for that, I think we are falling behind, as we say. Yes, sir.
What would a horizontal organization look like? Do they have different labels that cut across?
So I would consider, again, that's conjecture, right? So I believe one class on single mode AI, one class. Second class, multimodal AI. This is not the mathematics how to develop it, what it can do that students across the university take. Third potential, there are not too many, at least the way I see it. Decision making. Many fields have decision making capabilities, even to have the knowledge of a decision tree of, if this happens, you do this and so forth, simple things. I believe a small collection, 2 or 3 are probably sufficient, would give enough background for people to appreciate, and also you send the message, this is important. Like now everybody believes calculus is important, no? Because everybody has to take. I thought when I has that
Humanity.
to the admittedly, I have a biased view of the world. I have been 30, 40 years at MIT that, if you ask, you question calculus, they think you are crazy. And I don't question. I think it's useful. It's just that I have to augment the reality across horizontally. I guess the departure of the current is that we think of education of our young people as fragmented. We teach, you are a medical doctor, therefore you don't understand X. You are an engineer, therefore you don't understand Y. I believe this has a universality that I believe it's not. That's why I believe humanity students should take this stuff. It would be, that's of course my opinion, but that's what I am arguing.
One question about
One at a time, if you can.
So the first question is, how do you quantify interpretability in this context? And what do you think is the right balance between interpretability and performance?
That's the second question.
Yeah.
All right. First question, what is ability? So people use, I'm sorry to say, the analogy of pornography. I don't know what, I cannot define it, but when I have some, I even attempted to write papers on definition of interpretability, but at the moment, here's my criteria. When I present a result to my fellow doctors at Hartford Hospital, and they always ask me, why Dimitris is true? My current answer is, I don't know. If I change this answer, I say, this is the reason, I would say that's interpretable. This is not a mathematical answer, but it's a useful practical answer. And I acknowledge I'm not there yet. The second question, that's why I forget in my older age. So what was the second question?
What do you think is the right balance between interpretability?
I used to believe in my younger years that especially on life and death decisions, is to be interpretable. Okay? I'm on record on my current experience is as I'm not so dogmatic as before. I recognize we have things to improve, but on the other hand, I give you an example. This method saved a life. I'll tell you how it saved. That's the reality, not my imagination. So this method not only detects absolute measure of mortality, but increased. Humans cannot detect mortality at 2%. 2 and 5 and 10%. I mean, we don't understand. So this method, one day, this person says 2%. Next day, same person, 4%. Day after, 6%. Then it became red. The color, the absolute was not high enough, but because of the increase, it became red. It alerted the doctors. I did not understand why it became red, but it became red. So it became red. It alerted the hospitalist. The hospitals did new lab experiments they haven't done before, and they found the person has contracted sepsis. A day later, he will have died. It was not interpretable, I admit, but it saved a life. So therefore, my sort of, how should I say, dogmatic attitude that it should be, of course, it's a desirable, of course, it's the right thing scientific. So not in my peril, the person's peril. 2 more cases were similar, like they be open, adapt uniform. That would be 2 years, 2 years younger, and therefore less experienced. Another question? Yes, sir.
So I think that instead of the universities changing horizontally, what is needed is a new level in between universities and technical education. And those would be, higher level knowledge than currently technical education, degrees give. And it could be like the decision making through the science for multiple problems. But
how would you institute it?
well, that's
so. But I have a proposal. The proposal was partially adopted, not because I said, the university. The Schwarzman College is a horizontal structure that tries, not yet successfully, to educate young people in. It's called of computing, but practically it's the AI. But if you look at the hirings, all the AI people. So I think, I'm not saying that the Schwarzman College is the way to go. I'm not certain of that. But I do say some change is needed. You guys have a data science institute, right? Now, but the data science institute, in my view, while broad, is not broad enough. I think you should focus on the entirety, involve the agriculture. Maybe you already do it, and I do not know. I apologize for that. But be as broad as you can, because I think there is like an evangelist, but I definitely believe that. But it might have other structures. I mean, I don't want to discuss. Maybe there are other ways to do better. But I do believe this is a necessity scientifically, that we should educate young people. And because I engage a lot of young people in my life, I can tell you that even though they are not educated, if you educate them, I have educated 5 young doctors from the Hartford Hospital. Without me, they have published what I consider a fantastic new paper that, that they wouldn't have been doing it without this education. I mean, I think that's an example where, and I believe this has to come particularly with the young people, because young people, they don't have, I'm sorry to say, the baggage of experience, which I have, by the way. That's why I didn't believe, we form beliefs that, so I found that these ideas are more catching up with a younger audience. That's empirical observation I have observed. Perhaps young, not in number of years, but in mentality is the right. Okay, so these are some of my predictions. So let me tell you a few words about how my field, I mean, as you perhaps know, what is operational research, which is not well defined often. But I believe that my field should embrace this change, not fight it. Like I come from a tradition of very rigorous developments. If you look at the founders of the field and so forth, they believe in proofs, convergence, which is fine, which is great. I'm not saying it's bad, but we should not be at the same time abolishing ideas that are not as rigorous because they are useful, at least in my opinion. So I told you about the Swordsman College. There is, for sure, a challenge interpretability. And I think this is something at least my group and I'm certain others are currently working on it. We are trying to progress. I told you I was skeptical about deep learning as it felt it's too heuristic. And it's true. I was skeptical for a reason, and I remain skeptical on that part. But we should not forget its usefulness. So it is undeniable that deep learning is making significant progress to solve problems of significant. It's not only on games. It's not only on beating in chess or in AlphaGo and so forth. I don't find this that compelling. What I find more compelling is written developments, protein folding, matrix multiplication, drug development. But this progress has been primarily pioneered by companies who have the resources and so forth. But the fact that humans can do this with a lot of resources, admittedly, suggests to me that it's interesting. So there's another aspect that particularly for the young people in the audience, that I have learned. So you can take the perspective, we don't understand why deep learning works, but the damn thing works. And it does things that are, unfortunately, not understandable. For example, deep learning has had significant success by using a huge number of parameters, often more than the data, and uses particular stochastic gradient methods, right? But I thought, what a ridiculous idea that we have 500 million parameters and data is going on. If you do this in statistics, I don't think you will pass the qualifying exam, no? Right? But this is what is happening. The new models of OpenAI, one of my students told me they have 400 million parameters. I might be, but it's in the hundreds of millions, right? We don't have so much data. So there's something going on. So we in optimization also view the world as convex being easy and non-convex being hard. That's how I was told. I don't think it's valid, actually. New phenomena emerge in high dimension. This is the opposite. This is deep learning for optimization. For example, there's evidence on this, that areas of global optima become very flat in high dimensions. So not theoretical evidence, empirical evidence. And also, it's also empirical evidence, stochastic methods avoid local minima. Annealing is a method like that. So the same phenomenon has been observed 20, 30 years ago in the simulated annealing setting. So I believe there is an opportunity to reconsider optimization in very high dimensions and algorithms that use randomness under this new lens. That is, we have deep learning. These methods have not been, if you look at the methods of deep learning, they have not been developed by optimizers. They have been developed by primarily computer science and experimentalists. But the fact is, we have empirical observation on that. I think it's time for us. And to be honest, I have, something I have found that is also perhaps didactic. If you take the perspective, what the hell are they doing? They are wrong. No progress will be made. If you take the perspective, they have something to contribute. Let's try to use what I have found to something in a useful way in the field that has a much more rigorous tradition. Maybe good things will happen. In fact, my group has made progress on this, but we are not ready yet to announce. Okay. And in fact, of an agenda for the future, I do believe that to make deep learning interpretable is a good area. I believe there's things to do on the mathematics of optimization in very high dimensions. And I do not believe convexity is the name of the game. Other things matter. I also believe that you can change healthcare through this type of multimodal methods, medicine, and you also can affect the training of medical doctors. These are things I have high degree of confidence because I spent 15 years studying. I also believe it will change other things, but I'm yet less certain on the matter. And just to summarize, what I hope would be the some takeaways from the talk so that if people ask you, what did Bertsimas talk about, at least you will remember something about it. Number one, think about multimodality as a new paradigm for science, engineering, and medicine, that I do believe universities will be affected, and our field as well. My field should adapt. We can learn from the success of deep learning. And also, perhaps we should broaden the questions we are asking. For example, OR as a field, you know, it's sort of inventory theory, this and this. I believe under this perspective, this field is not OR anymore, but we can address with multimodal data a whole spectrum of fields. And especially because the majority of the audience are young people, the floor is yours, my friends. On that note, thank you.